औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम अल्लाहुम्मा सल्लि अला सय्यिदिना व मौलाना मुहम्मदिन व अला आलि सय्यिदिना व मौलाना मुहम्मदिन व बारिक वसल्लिम। Assalamu alaikum dear students. Today we will discuss about E.M.F, electromotive force. It is defined as the work done by the source to drive 1 coulomb charge in a complete circuit or in a whole circuit when current in the circuit is zero or when there is no current flowing in the circuit. Mathematically, E.M.F is equal to work done over charge. If work is equal to energy, then E.M.F is equal to energy over charge. Energy over charge. Symbolically, the E.M.F is represented by a capital letter E, a small Greek letter epsilon. Epsilon is just like a stylish E. This is a letter used for E.M.F. And energy or work done is represented by W or E, and charge is represented by a letter Q. The SI unit for E.M.F is volt, and the SI unit for work or energy is joule, and SI unit for charge is coulomb. So volt is equal to joule per coulomb. Dear students, keep in mind the E.M.F is also known as the voltage. The voltage of the source, battery or generator is called E.M.F. E.M.F is 1 volt. If 1 joule work has to be done by the battery or the source to drive 1 coulomb charge. So the volt is equal to joule per coulomb. Let's suppose we have a battery of E.M.F 12 volt. 12 volt means 12 joule work has to be done by the source or battery to move or drive 1 coulomb charge in a complete circuit. How much energy or work is done to drive 1 coulomb charge is equal to volt. Let's solve a question. 9 joule work has to be done to drive a 2 coulomb charge. Find the value of E.M.F. So by using formula, volt is equal to work done per coulomb charge. Here the work done is 9 joule and the charge is 2 coulomb. So our answer is 4.5 joule per coulomb. 4.5 joule per coulomb mean 4.5 joule per coulomb mean 4.5 volt. So our E.M.F is 4.5 volt. Dear students, we use the sentence in the definition when current in the circuit is zero. Now we will discuss what is meant by this sentence. In explanation, we use this diagram. In this diagram, we have a 9 volt battery and a switch and a lamp. Voltmeter is connected across the battery. E.M.F is the voltage of the power supply or battery. Here in this circuit diagram, our E.M.F is 9 volt because we have taken 9 volt battery. 9 volt mean this battery is able to supply 9 joule energy, electrical energy to 1 coulomb charge. If a 1 coulomb charge flows in the outer circuit, the battery will provide 9 joule energy to each coulomb, the capacity of the battery. If we look at the reading shown on the voltmeter, when the switch S is open, when switch is open, no current is flowing in the circuit. Voltmeter, we check the reading of the voltmeter. The voltmeter will show 9 volt, which is our E.M.F. But as we close the switch S and current passes in the circuit, and our bulb lamp is light up. Now if we look at the reading of the voltmeter, when switch is on, voltmeter reading is less than 9 volt. The voltmeter reading dropped from 9 volt. There may be 6 volt or maybe 6.5 or maybe any other value, but it would be less than 9 volt. But if we again open the circuit, the voltmeter will again show 9 volt. When switch is open, the voltmeter shows 9 volt. When switch is closed, the reading of the voltmeter drops. Actually, when switch is closed, the drop in the reading is due to internal resistance of the battery. So every battery has some internal resistance. When the current flows, internal resistance of the battery will act. Some of the voltage is dropped across the internal resistance. That voltage is lost inside the battery. So our output voltage decreases from 9 volt. But when switch is open, no current is flowing in the circuit. The internal resistance of the battery will not act, so no voltage will drop across the internal resistance, and our voltmeter reading will remain 9 volt. In O level, the internal resistance is not included in the syllabus, so we can omit this sentence from the definition. When no current is flowing in the circuit, that sentence can be omitted. But in A level, this is the part of the compulsory part of the definition. I think we should write this sentence in the definition, even we are writing in O level or in A level. Dear students, for O level, as the internal resistance is not included, so we will say that the voltage of the battery is called E.M.F. even the switch of circuit is opened or closed. So we will consider that the value of the voltmeter which is connected across the battery will remain 9 volt. Now we will discuss, as E.M.F is abbreviation of electromotive force, but keep in mind the E.M.F is not a force, because the SI unit for force is Newton, but the SI unit for E.M.F is volt. Okay guys, voltmeter is used to measure E.M.F. Its symbol is as shown. Now regarding voltmeter, you must keep in mind two things. Number one, the voltmeter is always connected in parallel. Number two, voltmeter has very high resistance. As it is connected parallel, that's why its resistance is kept very high, so that no current should pass through the voltmeter, all the current must pass through the electrical component. Dear students, now we will discuss why a voltmeter has a high resistance. To understand this concept, we will use this diagram. In this diagram, we have a battery, switch and resistor R1 and lamp L1. When we close the switch S, the current will start flowing in the circuit and our lamp will light up. As the current reached at point A, as the current reached from the battery at point A, now it has two paths, one through the voltmeter and other through the resistor. Number one through the voltmeter and number two through the resistor R1. The voltmeter has very high resistance, so the current will not pass through this voltmeter. All the current coming from the battery will pass through this resistor because the resistance and current are inversely proportional. The resistance of the voltmeter is kept very high so that no current can pass through this voltmeter, and all the current coming from the battery should pass through the resistor, and energy will be utilized or used or consumed by the resistor. Dear students, now we will discuss the next concept, that is a potential difference, which is known as PT. Potential difference is defined as it is the work done to drive 1 coulomb charge between 2 points in a circuit. The formula for PD is same as of E.M.F. PD is equal to work done per coulomb charge. The potential difference is measured in volt and the work is measured in joule and charge is measured in coulomb. So volt is equal to joule per coulomb, as we have discussed in the concept of E.M.F. To elaborate the concept of PD, now we will discuss an example. In this example, we have drawn a circuit diagram in which we have a cell or battery. Let's suppose the voltage of the battery is 12 volt and there is a switch in the circuit and we have two electrical components. R1 is a resistor and we have a lamp L1. As we have already discussed, the voltage of the battery, which is 12 volt, it is our E.M.F. The voltage of the battery, power supply or generator, is our E.M.F. When we close the switch S, the current will start flowing in the circuit. The battery, due to 12 volt E.M.F, this is able to supply 12 joule energy per coulomb charge. If we suppose that 1 coulomb charge is flowing in the circuit, so battery is supplying 12 joule energy to each coulomb. So to the resistor R1, if 1 coulomb charge is passing through the circuit, the 1 coulomb charge has an energy 12 joule. But when this 1 coulomb charge passes through the resistor R1, the resistor will use some of the energy according to its resistance or capacity. Let's suppose that the energy utilized by the resistor is 8 joule. 8 joule energy resistors take from the 1 coulomb charge and convert into other forms. So the 1 coulomb, after passing through the resistor, now it has a energy 4 joule. 8 joule energy is utilized or consumed by the resistor in other form. If it is a heater, it will convert 8 joule electrical energy into heat. Due to this energy change, there is an energy difference across the resistor R1. If we connect a voltmeter, if we connect the voltmeter parallel to the R1, this will shows 8 volt. 8 volt mean 8 joule per coulomb energy has consumed by the resistor. So this causes the energy difference across R1, which is the potential difference. This is known as the PD, the energy difference between 2 points in the circuit. Before lamp, now 1 coulomb charge has energy 4 joule. If 4 joule energy is utilized by this lamp and it convert that electrical energy, 4 joule electrical energy, into light, 1 coulomb charge after the lamp will have 0 joule energy. Now the energy difference across the lamp is 4 volt. That is our PD across the lamp. To summarize this concept of PD, generally we will say that the potential difference is only created when current is passing or flowing in the circuit. How many components we have connected in the circuit? Each component will use or consume some energy. So the energy difference before the electrical component and after the electrical component will be our potential difference. Dear students, now we will discuss the differences between the EMF and potential difference PD. Number 1, EMF is the voltage of a whole circuit, but the potential difference or PD is the voltage between 2 points in a circuit. Number 2, in EMF, non-electrical energy is converted into electrical energy, but in PD or potential difference, the electric energy is converted into other form or non-electrical energy. Dear students, I hope you have understood the differences between the EMF and PD. EMF and potential difference both we measured by using a voltmeter. Dear students, now we will discuss the resistor. It is an electrical component which provide hindrance or resistance for the flow of current in a circuit. The symbol for resistor shown in the diagram. You already know that solid, liquid or gases, all material have some resistance when the charge or current flow through that material. Basically, a resistor is made up of some material. Resistor is represented by a letter R. R is used to represent the resistor. The SI unit for resistance is ohm. The resistance is measured in ohm and it is represented by a letter omega. If any resistor have a resistance of 100 ohm, then we will write it as R is equal to 100 ohm. There are two types of a resistor. Number one, fixed resistor. This is the symbol used for fixed resistor. A fixed resistor is that resistors. The fixed resistor is that resistor which provide constant resistance for the flow of current, which has a fixed resistance. Its resistance cannot be changed. Some fixed resistors are shown in the diagram on left side. The second type of resistor is variable resistor. Its symbol is as shown. The resistor which resistance can be changed or varied is called variable resistor. So every variable resistor have some range of resistance. Its value have some range. The variable resistor resistance can be from 0 ohm to 100 ohm or maybe any other value. The example of a variable resistors is the volume key of the tape recorder or deck, which is used to change the loudness of sound. That is a variable resistor. The knob of the deck is a variable resistor. Similarly, the fan dimmer, which is used to change the speed of the fan, is also a variable resistor. Rheostat is also a variable resistor. Its symbol is as shown. It consists of several meters wire. By varying the length of the wire, we change the resistance. Dear students, now some important points regarding a resistor. Number one, the resistor can be used to divide the voltage. So we can say that resistors can be used as a potential divider. Number two, resistors are also used in the circuit to control the amount of current. According to Ohm's law, the resistance of a resistor can also be defined as it is the ratio between the potential difference across that resistor and the current passing through that resistor. So we can say that the resistance of a resistor is equal to V over I. Dear students, now we will discuss how resistors are used to divide the voltage. For this, as we have connected this three resistors in this diagram, battery of E.M.F 12 volt and a switch, three resistor R1, R2 and R3. As we have connected three resistors in series, so when we close the switch, the current will start flowing in the circuit. So the total EMF 12 volt now will divide into three parts. The total supply voltage is 12 volt. By connecting three resistors in series, we can divide this 12 volt into three parts. Total voltage can be divided into different parts by connecting resistors in series. Division of the voltage depends upon the resistance of the resistor. Higher the value of resistance, more is the potential difference across it, that resistor. More is the potential difference across that resistor. So generally we can say that we can use a resistor as a potential divider by connecting the resistor in series. Discuss the second point, how the resistor is used to control the current in the circuit. Now for this we will discuss this diagram as shown. In this diagram again we have a battery which has a constant EMF of 12 volt. When we close the switch, the current will start flowing in the circuit. In the diagram, we have connected a variable resistor. Variable resistor is that resistor, its resistance can be changed. So, by varying the resistance of a variable resistor, the resistance in the circuit can be changed or varied. Now if we increase the resistance of a variable resistor, the current in the ammeter, the reading of the ammeter will decrease. Higher the value of the variable resistor, lesser is the current shown by the ammeter. But if we decrease the resistance of this variable resistor, students, as we increase the resistance of this variable resistor, the total resistance in the circuit increases. This decreases the value of current in the circuit. So we can say that if the supply voltage is constant, resistance and current are inversely proportional. If we decrease the resistance of a variable resistor, we will see that the current shown by the ammeter will increase. So by varying the resistance in the circuit, we can control or change the amount of current in that circuit. Dear students, today we have discussed E.M.F, potential difference and resistor. Inshallah, in next lecture we will discuss Ohm's law, its graph, the graphs of non-ohmic conductor and resistivity. Thank you. Take care beta. Allah Hafiz.